Okay, welcome to section 1.6. Here we're going to talk about factoring. I'll keep this one pretty quick. It starts out on page 68 in the textbook, and they start with greatest common factor. There's kind of some steps that you want to know whenever you're factoring. You always want to look for the greatest common factor first. So if you can pull that out, then it makes factoring out a lot easier. Then you look at grouping. So you'll start with greatest common factor, see if you can pull something out. Then look at grouping, see if you need to group. Little hint here, in this textbook, whenever you see 4 terms, you will want to group. They basically guide you to a lot of these. So when you see 4 terms listed, think grouping and just split them with the first 2 terms and the second 2 terms. You'll see when we get there. So then they go over to leading coefficient of 1. Those are the easiest. They can add leading coefficients. It just makes it a little trickier when we start factoring. Page 71 talks about factoring trinomials by trial and error. I still do that. There's little methods that you can use. You can Google, you can find some different ideas, but they really still boil down to just give a few options a try. I keep track of which ones I've done just so that I'm not using the same one again after 4 tries or 5 tries. So you'll see what I'm talking about when we get there. Then they jump into examples. They talk perfect square trinomials and the difference of 2 squares. We already did that in section 5, so I'm not going to write that stuff down. That's section E and F in the textbook. You always want to look for those. Look for the perfect squares. But again, I'm not writing them down because we already did. What I did write down, I'll switch over now. The sum and difference of 2 cubes. So let me share my screen. And right here, you'll want to know these. You'll want to know the perfect squares, or perfect cubes. Sum and difference of perfect cubes. There is a formula. That's it right there. If you see a perfect cube plus a perfect cube, you use this formula. If you see a perfect cube minus a perfect cube, you use this formula, and you just plug them in. So look for perfect squares and perfect cubes, because then you have formulas you can follow. So I wrote down some numbers I want to do out of problem set 1.6. So in problem set 1.6, we'll start with number 11. Now, this very first group is telling us to look for the greatest common factor. So again, the textbook really does guide us. That's why students a lot of times do pretty well on homework assignments and then sometimes falter on tests. Don't worry if you're one of those people, you're not alone. The textbook sets up exactly what you do, what steps to follow, which category they fit. Then on the test, everything a lot of times is jumbled together. When I structure my tests, they are in order from section 1 all the way on. So that helps you follow along a little bit and understand what concept to use. So for number 11, we have 4x cubed minus 16x squared minus 20x. So for greatest common factor, I'll write it to the side here. Greatest common factor is whole numbers and variables, anything you can pull out of there that's the same. So initially, I see a 4, a 16, and a 20. I know I can pull a 4 out. 4 divides evenly into all 3 of those. So then I look a little further, and I have an x cubed, well, I have an x squared, and then I have an x. So I can pull 1 x out of there. I can't pull x squared because this one only has an x. You always go with the lowest. So I pull a 4x. Let me write it down here. I'm going to pull a 4x out of there. When I do so, I'm left with x squared here. So first step, pull out your greatest common factor. I did so, 4x. When I do, I'm essentially dividing each one of these by 4x. Divide 4 by 4, I'm left with 1. Divide x cubed by x, I'm basically just pulling 1 out. Whenever you're pulling out a greatest common factor that's a variable, you're just taking 1 away from the exponent. If you pull out an x squared, you're taking x squared out of each one. All right, so I took that. Then 4 divides into 16, or I should say 16 divided by 4, but 4 divides into 16 4 times. And then I had x squared, I pulled 1x out. So I had x times x, I pulled 1x out. And then here, 20 divided by 4 is 5. I pulled the only x out. So what I end up with for for number 11 is a 4x out here, and then x squared minus 4x minus 5. We're not quite done yet. We could be, but we're going to check. And what I see is a trinomial that I can factor. I know I can factor this because I have a 5 here. So I know I have a 5 and a 1. I need a negative. I need a negative and a positive. I can have a negative 5 times a positive 1. If I have negative 5 times positive 1, I have a negative 5. If I add those two together, I'm left with 4. So I know that one works. Once you get comfortable with factoring trinomials, you can guide yourself to the answer before you start trying a lot of times. So I'm going to break this down. It doesn't matter what we do first as far as positive, negative. But I pulled my 4x out. I factored x squared minus 4x minus 5 into x minus 5 times x plus 1. I know that works because my first term here is x times x. That gives me my x squared. Then I'm going to have x times 1 is 1x. Negative 5 times x is negative 5x. The difference is negative 4x. Negative 5 times 1 is negative 5. So I pulled out a greatest common factor. Then I still had to factor the trinomial. Now that's it. We're done there. Now I want to jump to number 21. Number 21, factor by grouping. They tell you, the book tells you 19 through 25 are factored by grouping. I only refer to the odds because that's what you're doing for homework. Every now and then I do an even problem on here if it directly relates to one of the odds. Okay. So this one throws people off a lot of times. I'll tell you that, the grouping. What you want to do when you're grouping, when you see 4 terms, I mentioned this earlier, when you see 4 terms, just know automatically that you are looking at 2 different groups. And you don't have to worry about splitting them and looking at the first term and third term and second term and fourth term. Just go ahead and look at the first 2 and the second 2. I believe every single grouping problem in this textbook is literally split with the first group and the second group. So what you're looking for here is what can you pull out? You're thinking greatest common factor. Even though it's called factor by grouping, what you're doing is looking for the greatest common factor of each group. So I look at the first 2 terms, my first group, and I see a 3. I can pull a 3 out. Then I look at my x. Nope, I don't have another x, but there's a y and there's a y. I can pull a 3y out. When I do, I pulled the 3y out of here. I'm left with x. I pulled the whole 3y out. It doesn't go away. It becomes 1. Now, you can always double check just to make sure there's not a simple mistake. 3y times x is 3xy. 3y times 1 is 3y. So that works. Now here, I'm just going to go ahead and do this, and then I'll explain what we're looking for afterward. You look for a greatest common factor. There's a 2, so I'm going to pull a 2 out. Then I look at a, and I can get an a out of both. I can't get that x out of both of them. Now what you'll want to do is, notice I did not write a sign here. The key, here's a group. Again, the book guides you. Let the book guide you. Let the book do some work for you. If you do this first group right, make the second group match. That's the key. Make it match. I have an x plus 1. I need an x plus 1 or I don't have a group. So when I pull this 2a out, I'm left with an x. And if I make this a positive 2 that I pull out, then this will be a positive. And I'll have a positive x plus 1, which is what I needed. Now let's say let's say we had a negative here and I pulled out a negative and I needed to change it. I could go back and just change this term here. This is the one that we can manipulate. You can make that whatever you want it. You need to make this match this. So whatever you need to do to this term to make it match is how you solve these grouping problems. So what we have here is, let me put this over here. If we had 3y times a, and we were adding 2a times, I should have chosen b. I'm going to change it to b. And we were adding to 2ab, I think all of you would just see this and say, oh, I can pull a b out of there. Look at that. Oh, there's a b. Woo! And I'd pull a b out. When I pull a b out, I'd be left with 3y plus 2a. You're thinking of this whole quantity as your b. Don't let the quantity throw you off. Treat it as one unit. So what I have is an x plus 1 that I'm pulling out. I'm factoring that x plus 1 out. So when I factor that x plus 1 out, I just write what's left. There's going to be two terms left. I stick them together. I have a 3y left, and I have a positive 2a left. Done. There's a grouping problem for you. Don't overcomplicate them. Look at the first two, pull out the greatest common factor. Look at the second two and know that you need that group from the first one. If you don't have it, you don't have a group. So spend your time on the first one. Let that guide your second group. Now I want to jump to 35. I'm going by what I've assigned here. And number 35 is in a different group. It says factor the trinomials. These are the biggest headache. When you have trinomials, it's typically going to be trial and error. The more comfortable you get with them, and they probably leave this one. Yeah, they're going to leave this one. The more comfortable you get with them, the quicker they are, because some of them you can get an idea in your head of which two terms are going to work, or which two numbers, I should say. So what we have is, this one's backward. Don't let that throw you off. I'm going to leave it backward. You can rewrite it, but I'm going to leave it back. We're used to seeing x squared plus 8x plus 12. And we would put x here and x here. They just wrote it backwards. So instead of our x going first, our x goes over here. That's it. We're still going to have a first term, a middle term, and a third term. And what we're looking at is this 12. When we're factoring trinomials, our leading coefficient of 1 with a variable, well, that simply means we have an x times an x. If we had any prime number as a leading coefficient, we would just have a 1x and whatever the number is on the other. Say we had 3x squared. We'd have a 3x times an x. So here, I know I have an x and an x to get my x squared. This term is the next one we need to worry about. This is multiplication. We multiply and we multiply. This one's found by the difference, by the addition or subtraction, whatever we have. All right, now, another issue is when we're dealing with positives, we know we have two of the same. We have positive and positive, or negative and negative. So whenever I don't want to draw it. Whenever this is positive, we know we had the same sign twice. That means this has to determine what that sign is. Right now, I automatically know I have two positives. That's the only way to get a positive here and a positive here. So 12, look, I'm going to do a trial and error and watch how this goes. If I do trial and error and just start throwing numbers out, I'll say, all right, let me try 4 and 3. Well, yeah, I get my 12, but then I get, here, let me do this. I'm going to do a few of these so you can see what happens with trial and error. I get 12. Well, then I get 4x plus 3x plus x squared. This middle term is 7x. That doesn't match up. So I know that one's out. The other option is to say, all right, well, and I don't want to do it here because it's going to be, well, what if I switch my 3 and my 4? When you have plus x, this is the same. It's not going to change anything. So we have to try something else. So we will try 6 and 2. Let me try 2 plus x and 6 plus x. When I try this, then I multiply the first terms, and this is the FOIL, first, and then outside, inside, last is what FOIL stands for. First is 6 times 2 is 12. Then I have plus 2x, and then I go to this term, and I get plus 6x, and then x squared. When I combine those, I have 12 plus 8x plus x squared. That works. So our answer, I'll write it clear here. Whoops, I'll spell it right though. I teach English too. Our answer then is 2 plus x times 6 plus x, or 6 plus x times 2 plus x. It doesn't matter what order they go in. If you think you got it wrong because the answer doesn't match up, just look at it a minute and see if they just have them in a different order. The deal is the quantity. You need the quantity to match up. Doesn't matter which order you go in. Okay, last one in this section is 53. Where's 53? Here we go. So this says, now they give us a factor completely. Factor out the greatest common factor if you have to. So what we have for 53 is 2x squared plus 7x plus 15. I have a 2, a 7, and a 15. I have no greatest common factor. X squared x, no x there. So this is an example like I mentioned earlier. We'll still do trial and error. However, you will have 2x and x. There's no other way to go about this problem to start it, because 2 is a prime number. So 2x and x. Now with 15, we can have 3 and 5. We can have 15 and 1. Now this is positive, and the middle term's positive. So I know they're both positive. Now what I would do in this case is I would take the 3 and the 5, and I would put one of them here and say, what would that be times 2, and see if I could get 7 from what's left over. So 5 and 3, I would put 5 here and say 2 times 5, well, that's 10. So 2 times 5 is 10. If I had my 3 here, I'd say, can I get 7 from 3 and 10? And I know I can. So I am going to put my 5 here and my 3 here and double check. And I have 2x squared. Well, let me just write it. This is our last one in a second. 2x squared plus 10x 2x squared plus 10x plus 3x. And then plus 15. Now you can see what happens when we add this up is, I'll do it over here, we get 2x squared plus 13x plus 15. We needed 7x. So my initial mode of thinking was, hey, put 5 there because 10 minus 3. But I'm dealing with only positives. So what I'm going to do is I'm going to try switching. Oops, almost can't see that. I'm going to try switching which ones I have. And I end up with, when I do that, I end up with 2x times x, and that gives me 2x squared. And then I have a 6x, and then a 5x, and a 15. And I say, well, dadgummit, what happened there? And I can't get anything from that. I can get 2x squared plus 11x plus 15. Now I had 13. That didn't match the 7. Then I had 11. That didn't match the 7. These are going to drive you insane, which is why I give you the odd problems to work on. So once you've done that, you can think, okay, my next option, and I'm running out of paper, so I might just give it to you here in a minute, but my next option is using 1 and 15. You still have that option, 1 and 15, but you should know that there's no way you're going to get 7 out of that, because you're going to get a 2 times a 15 is a 30, and either way you're adding together. So then you could do a 2 times 1 is 2. You're still going to have a 15. What happens in this case, after all that time and hassle, you can't do it. That's what's frustrating about this one. That's why I wanted to work this one out in the lecture video, because I don't want anybody pulling their hair out. I've done that already. See that? From too many math problems. Anyway, this is a prime. It means we can't do anything with it. We can't factor it. I believe that's the only one. Yeah, that's the only one that was prime. That's why I chose that one to work out. You won't have one like that on a test, because I think that's a trick problem, and I don't like trick problems on tests. When you have anything to factor on a test, you will factor it. So you won't have to worry about wasting 10 minutes, 15 minutes working on factoring, going back and checking. Just know that there won't be something like this on the test. Okay, that was section, I think that was the only one I wanted to do. Yeah, that was section 6. I'm going to do section 7 in a separate video. It's been real. I'll